Okay, welcome back. The next talk is from Boris Parak, and he is talking about rOCCI. Thank you.
Hello everyone. I hope you can hear me. So as I was already introduced, I will skip that. I would like to introduce my colleague Zdeněk Schuster, who is also working on the rOCCI project. Stand up and wave. Okay. So a short introduction for those of you who don't know what CESNET is a Czech education and scientific network provider. We are a member of the EGI and we manage the national grid. As a member of EGI, we are one of the participants in EGI Federated Cloud, which is an effort of EGI to create a federation of privately owned cloud services. At the moment, we have about 20 resource providers, or I should say certified resource providers, and almost half of them are running OpenNebula. The rest is OpenStack and various smaller cloud solutions. For example, Greek CNFO. So what's the big picture here? In the EGI Federated Cloud, we have an infrastructure that's separated into small blocks, and we are trying to use open standards. So in the example, you can see that in the middle we have the cloud management stack or the cloud management framework, which could be OpenNebula in this case, and then we have some connectors or some points of the framework we identified and which we need to make universal or to hide differences in between different cloud management stacks. So we have OCCI for virtual machine management, which I will talk about later. Then we have CDMI, we have information discovery, we have authentication, we have accounting, monitoring, and image management. What has been our experience with OpenNebula? At this point, I will switch hats because I am a resource provider, or we are a resource provider, but at the same time we are a technology provider since we are writing software components for EGI Federated Cloud. So as a resource provider, as a site running OpenNebula and contributing resources to EGI Federated Cloud, we can appreciate that OpenNebula is quick and easy to deploy, has very little overhead. You don't have to install various daemons or components on physical machines. It uses SSH, SCP, fairly known and stable ways of accessing hardware. It's very easy to administrate, easy to understand. It's not too complex. It scales well for medium-sized sites. So if you have tens or hundreds of nodes, physical nodes, you can very easily scale with OpenNebula. It shouldn't be a problem to monitor, to deploy virtual machines. If you go into thousands or tens of thousands, you could run into problems, but this would depend on your infrastructure and configuration. So you would have to test whether OpenNebula is the right solution for you. And it is also great for very heterogeneous infrastructures and various hacks. Since we are also a grid site, we have some very specific grid requirements. We have some software or solutions we have to integrate in order to submit accounting or to allow users to authenticate with credentials we provide to the rest of our infrastructure. So OpenNebula is good for hacking, basically. You can make it do whatever you want. As a technology provider, we definitely appreciate that OpenNebula is easy to customize and has incredibly flexible concept of resource templates, which if you are trying to make software that runs on top of OpenNebula, it's very useful to have, for example, virtual machine templates in which you can store information, because you can extend virtual machine templates and include new information inside them, then read it back. So that's a very nice feature. It's also backwards compatible between minor releases, which is also nice since we don't have to release new version of our components every time OpenNebula is updated. So we release one version when OpenNebula is transitioning, for example, from version 3 to version 4 or from version 4 to version 5, and then we can pretty much keep the software as it is. If we need additional functionality, of course, we can upgrade, but if there is no need to use the new functionality, we can use the old XML RPC or the old clients provided or libraries provided by OpenNebula. What is a little bit sad is that the developer documentation would need some code examples because in the beginning it's quite difficult to understand how it all works and how I can use libraries OpenNebula provides in Ruby or in Java, since these libraries are quite low level and provide access to underlying XML. So some very nice examples of actual usage outside of existing clients, which I can read and try to figure out how it works. It would be nice to have some additional documentation. And also something we mentioned yesterday during the hacking session, it's sometimes difficult to integrate advanced authentication methods, which goes a little bit against the the last statement in the resource provider section. But as I said, there are two different hats. In one section I am developing something, in the other section I am simply using OpenNebula. So that's our experience. As you can see from the green plus signs, it's mostly positive. So going back to the big picture, as I said in the beginning, in this presentation I will focus on virtual machine management or compute, which is the terminology used by OCCI. The rest, unfortunately, we don't have time for. OCCI, for those who don't know what OCCI is, it's an open cloud computing interface, and it's basically a generic text-based boundary level protocol, which means it's not specifically designed for cloud or for infrastructure as a service cloud. It's a modeling language in which you can model resources, relationships between resources. So it can be used for pretty much anything, especially if you focus on OCCI core. You can control doors with OCCI. It doesn't matter. You simply use resources and somehow represent relationships between resources, and it can be modeled in OCCI. Of course, since we are talking about cloud, we are using OCCI infrastructure, which is an extension introducing some cloud-specific features and parts of the OCCI standard. And then we have rendering documents which actually specify how OCCI should be rendered over the wire. At this point, there is HTTP rendering, which renders into plain text. As I said, OCCI is designed with extensibility, and you can basically make it do whatever you want. So it's usable for infrastructure as a service, platform as a service, service as a service, brokering, monitoring, and all that, all those nice terms. Some of these are already in development or in the design stages at the protocol level. So there are drafts of standardized documents, and hopefully will be released soon. To give you a better idea on how OCCI works, here is an example. I mentioned resources, so here is a compute resource, which is the actual virtual machine, for example, running in OpenNebula. Then you have storage resources, disks in OpenNebula, and then you have a network resource, which connects a virtual machine to the network. And then you have OCCI links of various types, which represent the relationship between resource compute and resource storage or resource network. There is also a concept called OCCI mixins, which are used to extend resources. So you are launching a virtual machine, you have nothing to add, okay, just launch a virtual machine. But if you have a virtual machine which supports contextualization, you can add, in runtime, you can add the OCCI mixin, which will introduce contextualization support, and now you can provide the machine with user data and change it as it boots up. Going away from standards and EGI Federated Cloud a little bit, the software component or the software components we are writing for EGI or EGI Federated Cloud are called rOCCI or rOCCI if you like to spell. And we provide a few libraries meant for developers, such as rOCCI API or rOCCI Core. So if you have a Ruby application and you would like to introduce OCCI support via native Ruby libraries, you can use Core or API, which are designed to be mainly client-side. Core is universal. It simply represents the standard. It implements classes. API is client-specific. It implements transport protocols, HTTP, some authentication plugins, which will help you negotiate authentication with different cloud frameworks behind OCCI. And then we provide ready-to-use end-user components, which are CLI and rOCCI-server. CLI is a client. It has a very basic shell interface, so you can call it from shell or command line and interact with different clouds behind OCCI. And rOCCI-server is a server-side component used to introduce OCCI support to frameworks, two cloud frameworks which do not have OCCI support. For example, OpenNebula. The whole point in using OCCI is also, of course, you can use different OCCI compliant clients and servers. So it doesn't have to be rOCCI to be compatible with rOCCI clients or rOCCI servers. You can simply use whatever client that can talk OCCI, and you should be able to interact with these components. Coming to rOCCI CLI, I won't go into technical details, but as you can see, it's a Ruby gem or a native package. You can install RPM or deb, and then you can run simple commands when you can tell the client to create something. The something you are creating will be OCCI compute. It will be Debian. This is the mixin that will identify the operating system. The next mixin will identify the size. This is very similar to EC, EC2. There are flavors and AMIs. Then you can specify some attributes, title of the virtual machine, some details, how many cores, how much memory, that sort of stuff. And then you can, as I hinted before, include contextualization, context attributes, public key, or directly user data. So if you use Cloud Init in your virtual machines, you can skip public key and just provide user data. And inside with Cloud Init, you can add your public key, create new users, or do fairly complicated things with the virtual machine as it boots up. Once the virtual machine is already running, you can use the describe action to get some information about it. In general, you need at least the IP address, since you need to interact with the machine. So you will get a long output from the command, and one of the information included in the command is how many disks are attached, where they are attached, how many network interfaces you have, IP addresses of those interfaces, some basic information about the machine. Then you can execute some actions on the machine: stop, start, resume, suspend. It depends on the underlying framework, whether it is supported. There is a OCCI discovery interface which can actually tell you beforehand what is declared to be supported by the server, so you don't have to do this blindly. And this is somehow supported by the client, so the client will tell you, okay, this is not supported, so it doesn't have to contact the server a second time. I can build a client in runtime, since it's written in Ruby and we use metaprogramming. So I build a client in runtime, and then you have the model is basically represented in the way how the client is built. And then when you at the end, when you are completely done, you can delete the virtual machine, which will trigger shutdown or whatever terminate action is in the underlying cloud framework, and it will remove the instance. rOCCI-server, the more complicated component from the rOCCI framework, is a server-side implementation, and it's built on top of rOCCI Core. So we are basically taking the representation of OCCI outlined in rOCCI Core, and we are building a server-side implementation on top of it. And it's a bridge between almost any cloud framework, which is introduced as a backend with the world of OCCI, which is handled internally by the server. So the idea is that you can write a backend without deep knowledge of OCCI. We can sort of push you the right way into the right methods and the right return values, so you don't have to understand OCCI in depth to develop a backend for rOCCI-server. We also support authentication plugins, and we have a few backends. OpenNebula is, of course, it was the first backend. It was originally designed for OpenNebula. It's still the most feature-complete backend. Then we started introducing new backends, mostly as requests from EGI Federated Cloud, since there are different cloud frameworks, and we already have a machinery to enable OCCI on them. So we are using this as a generic bridge between cloud frameworks and OCCI. From the last year when I spoke about OCCI, we managed to completely redesign and rewrite rOCCI-server, because in the beginning it was basically a proof of concept application. So yeah, it worked, but it wasn't nice to administer. It was difficult to debug. The performance wasn't great. There was hard-coded information inside, so it wasn't really fit for deployment. Year after, we have a new design based on fairly standard components. As you see on the left, we have Apache HTTP server, mod SSL modules, Fusion Passenger. For those who program web applications in Ruby, is basically a mechanism to run Ruby applications inside HTTP servers. Then there is the server, and through backends it can interact with different cloud frameworks. The internal design of the server, although simplified, is here. So we have a bunch of layers. The request will pass through when coming to the server and leaving the server. So we have authentication, parsers, hooks, and then the core, which will access the underlying framework, will access OpenNebula, retrieve relevant data, convert it to OCCI, make some modifications, smooth the edges, so you don't actually see the platform-specific details of OpenNebula underneath, and then render it and send it to the client. Through the system of hooks, the server is fairly modifiable, so you can add pre-processing, post-processing on messages. You can add new authentication schemes, but in general, we are trying to delegate as much as possible to the underlying OpenNebula, for example, because we don't want to do user management or handle access lists or whatever. We are simply converting the incoming request from OCCI into native XML RPC, for example, calls. So most of these authentication methods are just conversions. So I know where Apache will give me this information. I will convert this information into something OpenNebula will understand and send it to OpenNebula. OpenNebula will authenticate, will handle ACLs, will show you the right resources. So this doesn't have to be done in the server, which simplifies things, because we would have to mirror the behavior to make sure that there are no split brain decisions between the server and OpenNebula. So how can you deploy rOCCI-server? You can deploy it on single OpenNebula, or you can have multiple rOCCI-servers on top of one OpenNebula. If you have user communities which are very different, you need different configurations. You can simply deploy multiple instances on the same OpenNebula. This also goes to the way that we delegate most of the functionality to OpenNebula. So for OpenNebula, those are transparent clients. So we are impersonating the user coming to rOCCI-server. So it's not a single user solution. The user will simply pass through the server and authenticate to OpenNebula with his own credentials. But what you cannot do is deploy one server on top of multiple OpenNebulas, because we don't do infrastructure management or load balancing or whatever. It's simply a different API, so we cannot choose which framework to, which instance of OpenNebula to access. We simply can pass the request. We also added logging, debugging tools, and all those nice things that admins or operations need to actually make it work, so you can install it reliably, you can see what's going on. We have a Logstash plugin that actually logs incoming requests into Logstash, so you can see how your infrastructure is doing. You can search for exceptions beforehand, and it's quite nice to administer. And you also don't have to install it by checking out the GitHub repository, which is a big plus if you manage an infrastructure. So who is using rOCCI? It's mostly, let's be honest, EGI Federated Cloud, because they are the big players. They are pushing OCCI. So we have end users which are directly using rOCCI client to interact with EGI Federated Cloud sites. Then we have external connectors mentioned below. Those are brokers or high-level applications which wrap rOCCI client and then basically simulate platform as a service or service as a service on top of infrastructure as a service through OCCI. So you can, for example, use Slipstream or Catania Science Gateway to create virtual machines without knowing you are creating virtual machines. You can simply submit jobs or design some sort of a workload with comps, and it will be deployed in virtual machines on the cloud in the background. You don't have to worry about it. We also have rOCCI-server deployed on multiple sites in EGI Federated Cloud. So each site using OpenNebula is using rOCCI-server. And we have some Nagios probes based on the rOCCI client, also monitoring all these various OCCI implementations and frameworks the same way. So we actually have a demonstration that this can be done without the probe knowing which cloud management framework is behind that particular OCCI implementation. We can issue the same command, and pretty much the same response will be sent to me, and I can create a virtual machine, can check the virtual machine, then I can destroy the virtual machine. And this is done periodically as part of the certification test and then part of regularly run Nagios tests. Here are some of EGI Federated Cloud user communities which are using OCCI and in part rOCCI, from large ones such as Atlas or smaller ones such as PeachNode, which is a OCR music score sheet reading in the Federated Cloud environment. It's available as peachnode.com. I think you can look it up and see some OCR music. So what's our roadmap for the next few months, possibly a year? We definitely need to explore new features which will be coming in OCCI 1.2, which is currently a draft and will be quite instrumental in helping us move forward, because we had quite a lot of input into the standard, clarified some things, added extensions. Some things had been reworked to work better in production environments. We would also like to add monitoring and accounting support to rOCCI, since drafts already exist, but we don't have the tools to use them or to allow you to interact with monitoring or accounting through rOCCI. We would also like to include some new renderings, because plain text is not always the best way to go. If you ever parsed plain text messages, you know that's not the right choice always. And we would also like to rewrite the client based on user feedback, so make it more usable, include some new features, basically abstract from OCCI, and you wouldn't have to use keywords like resource and mixin, but you could say, okay, give me a machine with disks and network, so you don't actually have to speak OCCI to be able to use the client. So in a summary, here are a few points. I won't repeat it. So thank you very much for your attention. If you have any questions, I will be happy to answer them.
Okay, any questions? Okay. Yeah. Just wait a moment, please.
And how is the difference going to an OpenNebula with OCCI or going to CloudStack or maybe OpenStack? Is that different when you?
When we in EGI Federated Cloud, when we communicate between different frameworks, in most cases we managed to smooth out the edges, so you actually don't have to know to which framework you are going. The biggest problem is at the moment authentication, because OCCI as a standard says almost nothing about authentication. So naturally each framework adopted its own authentication and then communicates with OCCI. And the OCCI, those OCCI messages are mostly compatible. We can parse them and we understand that's okay. But we still have to authenticate, which in case of OpenNebula is easy, because OpenNebula, the authentication is done in band. So I simply send a message. OpenNebula will decide whether to accept or not. And then I'm done, basically. In OpenStack, for example, I have to go to Keystone. So the client has to somehow detect or decide, okay, I received 401, I'm not authenticated, but in headers I found Keystone URI. So it's probably OpenStack, so let's look at the Keystone URI and let's try OpenStack authentication protocol. I will run the OpenStack Keystone authentication protocol. It will return a token, and then I will retry the connection to the original endpoint. This is most of the magic done inside the client. So we are hiding authentication differences between different frameworks. OCCI itself basically works.
Okay, thank you. More questions? Okay, nobody. So, thank you, Boris.
Thank you.